Alfred Plays, and today we're gonna get into some Xenobots. This is like part two. I don't even want to say part two, but it's gonna be a continuation of microbots. I'm gonna show you that they're using or going to use to control the body and the spirit. But yeah, man, we just gonna get into it.
What you're about to see is the first ever living robot that was just created by researchers in the US. This is it, the Xenobot. Under 1 millimeter in size, it's unlike most robots in that it's not made of any plastic or metal, but entirely of organic cellular material. It can move forward, turn around, sometimes spin in circles, and if you flip it on its back, it will flip itself back over. It's a human-made robot, but it's alive. Now, you might be asking, what exactly is a living robot? And that would be a perfectly reasonable question, especially given the fact that it's being deemed a brand new life form that has never existed before. But before we can actually understand what it does and what that might mean for the future, we have to understand what it actually is. Researchers essentially wanted to figure out if they could take real live cells and make them behave in a way that the researchers wanted them to, much like a robot made of other materials would do. So they took two different types of frog cells, both skin and heart cells. Heart cells naturally contract while skin cells don't. So the idea was, if we can put skin cells and heart cells together in a specific way, maybe we can come out with a functional structure that can move. And that's exactly what the researchers tried to do. If you take a look at this video of one of their successful creations, you can see that the blue cells are non-contracting skin cells, while the green and red ones are contracting heart cells. So this particular combination of cells will give you the motion you're seeing in both the animation and the actual result below. But it would have taken a long time to get here. So using computer scientists and evolutionary algorithms, a supercomputer would have made millions of iterations of these combinations of skin and muscle cells to figure out which combinations make the best movements. And evolutionary algorithms would have worked much like natural selection to improve upon existing models to figure out what's better, ultimately ending in what would be deemed the most fit versions. And so the researchers then used these computer-made designs to make the real thing. And by that, it means taking one cell at a time and sticking it to the next one and then to the next one. It's an extremely laborious process. Luckily, cells have the natural tendency to want to stick together, but it still meant a human technician going through a really intense process one bit at a time. So what exactly makes them robots? Well, once the scientists understood which combinations would make a cell move in a straight line or make this one spin in circles, they could then tell the supercomputer, we actually want this type of movement or this type of action. How do we get that? The supercomputer calculates it and then gives them a design that will ultimately create that action. So if the Xenobots are designed in the exact right way, they can move in the exact way we want them to. And so we end up with cellular organisms that have been designed by humans to act in predictable manners, like robots, which is what the Xenobots are, really. But the interesting, or kind of freaky part, is related to something called emergent behavior. While we might understand how a single cell works, when you put a group of them together, sometimes emergent behavior or properties come about. So the single cell itself can't do this thing, but when it's in a big group, it does. And us humans, assuming we're all humans here, are perfect examples. We have trillions of cells in our body, none of which have on their own consciousness or the ability to think, but when you bring them all together in this particular combination that is a body, consciousness emerges. What surprised the scientists about the Xenobots is that sometimes they would change their movement. They might turn around and go back from where they came from, or link up with another Xenobot and travel around, or if they were cut in half, they would put themselves back together. So truth be told, these Xenobots weren't completely predictable, but that was part of the research and the study. If we were to put combinations of cells in certain ways and get action that we were wanting, what types of other emergent behaviors could we see so we could better understand the whole system and better make Xenobots in the future? And that's what makes Xenobots so different from your traditional robot, which is made up of individual dumb parts, sorry robots, don't want to offend you, that when put together make up an intelligent whole, whereas the xenobots are made up of individual cells that have the inherent qualities of life, and in and of themselves are smart. Cells communicate to make tissue, which make organs, which ultimately come together to make us. So what does it all even mean? Well, the long-term implications are pretty massive. I mean, you don't need to be worried about a robot uprising anytime soon, and we can't even really tell these xenobots to do anything yet. But the more we learn about them, the more potential there is, and there's some pretty cool suggested future uses for xenobots. Picture this, a swarm of xenobots made using your own cells that are deployed internally in your body and sent to your brain to help remove a brain tumor. And because they're your own cells, your body won't reject them. Or picture cleaning up artery plaque in your body using xenobots. This generation of xenobots was used only using skin and heart cells, but the future ones could be used using photoreceptors or other types of cells to help them navigate and understand their environments. Why not build some with components from blood vessels, nervous systems, or sensory cells to make a rudimentary eye? Outside the body, picture something like the ocean, which is littered with our plastic pollution, in particular microplastics. Maybe these xenobots are used to target and break down microplastics or collect them and clump them together so that they can be more easily removed. And the great part is, because they're biological, they naturally break down. So in this study, the xenobots lasted between 7 to 10 days before they stopped functioning and broke down. And while these suggested uses are definitely far down the line, they show the massive potential of these xenobots. Unlike plastic and metals, which in your body, as an example, would be detected as foreign objects and it would cause a lot of problems. So what does the future of this look like? Well, one of the biggest question marks right now is the ethical implication. Once you start creating these robots that have cognitive capabilities and can sense things, and we're selecting them based off of their abilities to think and do things, who is going to be protecting their rights? Do they become organisms that ought to have rights in the first place? If these are organisms that are actively participating in our world, and maybe some can feel pain because it's a benefit to their function, or maybe they can start to think, what does that mean? Where do we draw the line? The researchers did acknowledge this as uncharted territory, and the fact that we should be having these discussions in the early stages of technology like this, so that the public can understand, that the governments can make informed decisions, and that we can all feel positive that we're doing something good in the world with it. Personally, I found this research to be so fascinating, and it led me to be excited and also terrified at the same time. You know, the potential to address climate change with something like xenobots, or health and safety of the human body in delivering drugs. These are all amazing things, but at what cost does it come? How do we prepare for what else these biological robots could be used for, and how do we address the concerns that they could very well be considered living organisms made of human cells, made of other animal cells that are biological? You know, we've had these conversations about artificial intelligence and robots, and at what point do we deem them to have rights for themselves, or to have feelings and those kinds of things? This is just going to skyrocket that problem into another level, because these beings are actually made of biological cells. So fascinating, so interesting. I am really curious what everybody else thinks, because to me it's exciting and terrifying. I think it can be both at the same time. I don't think the robot apocalypse is anywhere near, but I do think it's something to keep in the back of our minds, just in case. Just in case one of these Xenobots are watching this video in the future, though I love you, and I promise I never questioned your good intent. I hope this video was useful and interesting to you. I had a lot of people asking to go a little more in depth about Xenobots, because it's a huge discovery and breakthrough, and I thought it was worthwhile to understand a little more of the intricacies of it. Let me know if you have any other questions, but comment down below. What do you think of this technology?
Alright. Like, comment, subscribe. Like he said on what you thought. Them xenobots can be used for, I know many ways they can be used for biological warfare, you feel me? Take over a little country real quick, like, ooh, shoot, ooh, ooh. It's your boy in there for the place, man. Like, comment, subscribe. Stay fearless. Stay focused. No fear.